Welcome to Exquisite.
Those were so many balls, Sensei.
Yes, Titi. In today's class, we will continue to learn about mirror balls. If you recall, in the previous class, I told you to see curved mirrors as parts of mirror balls.
Yes, Sensei. I remember, you told me that if I had a mirror ball like this one, and then, if I slice out a section of it, that way, then what I have is a curved mirror.
That's correct, Titi. Now, you know that every ball or every sphere has a center.
Yes, I do, Sensei.
For instance, the center of this sphere is at this point.
That's true, Sensei.
In curved mirrors, we refer to that point as the center of curvature.
Oh, I see. Are you saying that the center of curvature of a curved mirror is the same as the center of the sphere from which the mirror was cut?
Yes, exactly, Titi. The center of curvature of a curved mirror is the center of the sphere from which that mirror was cut.
Okay.
And just like in any other sphere, the distance from the center of curvature to the mirror is called the mirror's radius of curvature.
I understood that, Sensei. So, the center of curvature of this mirror is this point, while the radius of curvature is the distance from that point to the mirror.
That's correct, Titi. It means that mirrors which are cut from bigger spheres will have their center of curvatures farther away from the mirrors.
That's true, Sensei. And mirrors that are cut from smaller spheres will have their center of curvatures closer to the mirrors.
Brilliant, Titi. The radius of curvature is longer if the mirror is cut from a bigger sphere, and it is shorter if the mirror is cut from a smaller sphere.
That makes sense, Sensei.
Now, I also like to let you know, there is something called the principal axis of a curved mirror.
Okay.
It is that imaginary line that runs through the center of curvature and the mirror's vertex.
Please, Sensei. Where are you referring to as the mirror's vertex?
Exactly this point, Titi. Some people also call it the pole of the mirror.
Okay, I see, and I understand it now. The principal axis of a curved mirror is the imaginary line that runs through its center of curvature and its vertex.
Correct. Titi. Do you also remember from our previous lesson that the rays of a parallel beam of light will converge to a point after reflection on a concave mirror?
Yes, Sensei. That picture is still fresh in my mind.
Great. That point to which the rays converge is known as the principal focus of the mirror, but we will not talk about this in this class.
Why, Sensei?
Because I want your brain to get some rest. We will talk extensively about the principal focus in the next class.
That's kind of you, Sensei. Thank you.
Before we go, tell me the things you learned from this class.
Yes, Sensei. 1. The center of curvature of a curved mirror is the center of the sphere from which the mirror is sliced. 2. The radius of curvature is the distance from the center of curvature to the mirror. And 3. The principal axis is an imaginary line that passes through the center of curvature and the vertex.